Okay, good afternoon again, everyone, and welcome to our subject, SRFQ 423, Reinforced Concrete Design. And today we will go forward with our discussion about design of doubly reinforced beams. No? Kasi hindi natin siya na-cover for semi, so we will be continuing it here sa finals phase natin. Okay? So as a recall for this procedure, so when we say doubly reinforced beam, we are considering additional reinforcement do sa top fiber natin, which will cause additional compression force dun sa member natin. And we say from our previous discussion regarding the analysis of doubly reinforced beam na we assume that the tensile reinforcement provided at the bottom for singly reinforced beam, we call that as our AS maximum for singly reinforced lang. Pero once we introduce a reinforcement at the top of our cross section, that reinforcement is requiring a unequal reinforcement dun sa bottom natin, which will be added dito sa ating maximum for singly reinforced beam kasi i-counteract niya yung effect nung additional dito. So kung itong dalawang to is ano siya no, na tinutulungan o yung reaction niya is kina-cancel out niya yung each other, ibig sabihin yung makukuha nating value ng A o yung ating depth ng compression block, yung value ng depth ng ating neutral axis at this section or at this solution dito sa singly reinforced beam will not be different kapag naging double reinforced na siya. Okay? So later in our calculation, we will be um, encountering some of this, which is very important for us to understand. Okay? So, again, yung total moment capacity ngayon ng section natin will be composed of two parts, or we split it into two components. Yung MN1 is from the capacity niya nung singly reinforced pa siya, yung maximum capacity niya nung singly reinforced. Ibig sabihin, nung tensile reinforced pa lang siya. So, kaya dito nakalagay AS max. Okay? Pero we can call also AS max as our AS1 for doubly reinforced. Kaya ang papansin nyo dito, yung sa second one, AS2 na yung nakalagay, hindi AS1, ano? Ay, hindi AS1. So, para hindi lang tayo uh, ma-confuse, no, kung which is which. Basta kapag AS1, it pertains to the capacity of our section when it is originally reinforced tensionally lang. And then another capacity from our couple na to, from our compression steel and also our tension reinforcement, additional tension reinforcement due to the additional compression steel that we have provided at the top. Okay? So as a step or procedure, ito yung summary ng procedure that we can adapt in calculating for the design of double reinforced beam. So since we are pertaining to design, una syempre is to identify yung loading natin, and we can identify that by using basic na analysis ng structure. Kung halimbawa given ay mga pressure load, so we need to understand how to calculate dapat yung loadings natin, and depende sa type of supports natin. So basically, lagi namang simply supported usually yung sa examples natin, ano? So we are just using the formula of moment for simply supported beams, which is WL squared over 8. Then we were able to identify yung value ng MU. Okay, so after getting the value of MU, we can calculate the value of MN by assuming a phi value of 0.9. Why 0.9? Kasi since we are we are introducing another we are introducing compression steel dun sa ating top fiber, we are assuming na nag-yield na o na-reach na yung yield strain ng mismong nung steel reinforcement natin sa bottom. Kaya i-assume natin na 0.9 na agad yung phi natin, ano? So dapat siya mag-yield. Kasi kung hindi siya mag-yield, maybe our cross section is ano pa, no? It will fall under yung transition zone natin. So magiging iba yung value natin for our phi, which will be based dun sa graph natin for compression, transition, tsaka sa tension control. na sections. Okay? Pero in the code requires us that for tensile reinforcement, ang gusto niya lagi siyang mag-yield. No? Yun yung sinasabi natin noon pa na kailangan mag-yield yung tensile reinforcement to attain yung ductility na requirement natin for our beam. Okay? So after getting our nominal moment, we can now calculate yung maximum reinforcement ratio natin. So dito yung term na maximum, it doesn't mean katulad to nung nakikita natin nung 2010 and 2001 NSCP, ano? Kasi ngayon sa code, we cannot see any section sa code na nililimit yung maximum reinforcement natin. Ibig sabihin, kahit ilan yung bakal as long as kasya siya or hindi siya bago-violate sa spacing, sa sa mismong mga checking natin, pwede tayo mag-provide kung gaano kadami ang gusto natin, ano, as a designer. Pero there are some cases, iba, check nga natin yung ET natin, ano, we are checking before, di ba, yung ETY natin, na meron tayong value niyan na at is ET plus 0.003. And sabi natin kapag ang FY natin is 420 megapascal, we get ETY as 0.005. This is actually a requirement from AACI, ano? So from the American Standards yan. Pero kay NSCP, ang nire-require niya, at least ang ETY natin, sabi niya, 0.004. Okay? So baka malito ko, ba't may ginagamit na 0.005, ba't may 0.004? Sa NSCP, ito yung nire-require niya, 0.004 lang. Okay? Pero anong problema pag 0.004 siya? Pag chinek natin yung graph nung ating tension control, ano? Yung di ba meron tayong graph na ganyan before. Okay? And then meron tayong straight line, then nag-increase tapos nag horizontal ulit, na itong section na to, ito yung 0.65, ito yung 0.9, ito yung sabi nating ETY plus 0.003, and then ito yung ating ETY o 80. Okay? 80. Okay? Papansin nyo yung 0.004, di ba itong babang to, that is equals to 0.005. And mapapansin nyo yung 0.004 na nire-require ni NSCP, that is within do sa transition zone natin. Okay? So pag nag-transition zone tayo, syempre yung value ng ating phi dito will be based dun sa formula natin na 0.65 plus 0.25. Then may factor dito na something. Okay? So kaya pag halimbawa nakita nyo sa problem, hindi in-state kung anong gagamitin na code, i-assume natin lagi na ACI o 0.005 yung ating maximum na yield, ano? And then kapag NSCP, 0.004. Okay? Kaya meron akong dalawang formula dito. So ngayon, saan nanggaling to? Saan na naman to nanggaling? Ano? Parang bago na naman sa mata natin. This is just based from our previous mga ginagamit na formula, no? Medyo nag-iba lang siya ng form, pero based lang yan sa basic knowledge natin ng uh, ng compression nung ano natin, singly reinforced, ano? So pakita natin. So we have a value. Halimbawa, di ba kung kailangan natin ay rho, ang formula ng rho natin ay AS BD. Okay? Yan yung formula natin. Sorry. AS is equals to PBD, rather. Okay? AS rho BD. Ito yung basic formula natin for area ng steel. And then, when we look at it, para makuha natin si rho, that is AS over BD. Okay? Now, when we look at our strain or stress diagram, makikita natin before, ito yung ating compression, ito yung ating tension. Pwede natin equate yung dalawa, T is equals to C. Yung T natin is ASFY, yung ating C ay 0.85 F prime C AB. Okay? So, we can get AS value as 0.85 F prime C AB over Fy. Then, we can substitute it back dito sa formula natin. So, 0.85 F prime C AB over BD. Okay? So, dito, pwede natin cancel yung B. So, matitira is 0.85 F prime C A over D. Okay? Then, saan natin makukuha si value ng D? So, meron tayo sa strain diagram naman natin. No? We have a value of 0.003. We have here, this is C. This is D minus C. And then, ito yung ating ET. No? So, sabi natin, alam na natin by formula yan na 0.003 D minus C over C. So, try natin i-simplify ito. Cross-multiply natin yung C. ETC is equals to 0.003. Distribute natin. So, D minus 0.003 C. Transpose natin yung parehas na C. That is 0.003 D. So, ETC plus 0.003 C. Or pwedeng D is equals to ET plus 0.003 over 0.003 times C. So, pwede natin substitute yun dito, mabalik ulit. So, that is 0.85 F prime C A. Tapos, that is 0.003 all over ET plus 0.003. Then, we have C. CA, alam natin CA, equal siya sa A beta 1. C beta 1 rather. O beta 1C. So, ito, magka-cancel out yung C. Kaya ang natira, 0.85 F prime C. Okay. Nawala yung Fy. Wait lang. Ito, no? May Fy ito. So, may Fy dapat dito. Okay. Over Fy, beta 1. Then, mangyayari dito, since maximum pinag-uusapan natin, sabi nga natin sa ACI, 0.005 siya. So, ito magiging 0.005 plus 0.003. So, 0.008. Kaya pwede maging 3/8 na lang siya. Okay? Which is, ito yung pinanggalingan nitong sa formula na to sa ACI. Okay? Then for NSCP, since yung ET natin magiging, yung EDY natin magiging 0.004. So that is 3/7. Kaya naging 3/7 to 3/8. Okay? So, you don't need to memorize this naman. Pinakita ko lang saan nanggaling. So, pwede na natin directly gamitin to when we are talking about the maximum reinforcement ratio na pwede natin gamitin for our doubly reinforced beam. Okay? So, ibig sabihin sa singly reinforced, ito yung maximum values natin ng raw max. Okay? Para, ibig sabihin, kailangan satisfy natin to para once na na-exceed yung value na to, tsaka tayo pwedeng maging doubly reinforced. Okay? So, once na makuha yung raw max, yan, proceed tayo sa next step. Calculate natin yung AS max. So, si AS max, edi si raw max BD lang siya. And then, calculate natin yung maximum o yung MN1. Okay, so that is just based from the calculated value ng AS max times Fy times yung ating syempreng ano pa din. Ito yung ating moment arm pa din na D minus A over 2. Okay? And then pag nakita natin na yung MN1 natin o yung ating maximum moment for singly reinforced beam is greater than dun sa MN natin, it means na kayang-kaya ng section natin ng tension alone. Okay? Kaya singly reinforced beam lang siya or SRB. Okay? May mga nakikita kasi kayong acronym na ganyan, SRB. Then otherwise, if kulang yung moment natin with regards with our nominal moment, yung MN natin galing yan dito sa step 2 natin. So kung ganun yung case, beam is designed as doubly reinforced beam. Okay? So DRB siya, ibig sabihin. And then we will proceed to the next step. Okay? So once na na-prove natin na doubly reinforced siya, yung na-calculate natin MN1, gagamitin natin to calculate for our MN2. Okay? So again, yung ating notation na yan, nanggaling po yan dito. Kaya calculate natin yung MN1, yun yung maximum para sa singly reinforced. Ngayon, pag kulang siya, so ibig sabihin, kailangan mo ng additional moment para masustain mo yung required o yung kailangan niyang isuportahan. So kaya papasok si MN2. Para makuha natin si MN2, si MN1, itatranspose lang natin dito sa kabila. Okay? So, yun yung meaning ng step 6. Okay? Ayan. So, from this equation, nakuha natin to. Then, once na nakakuha natin sa MN2, yan, may dalawa tayo syempre, ano? Um, yung, yung force makukuha natin due to our tensile, due to our compression steel. Okay? So, lagyan nga natin to. So, ito yung sa compression steel, ito yung sa tension, ano? Lagay natin T2. Yung dalawang yan, syempre, it's a couple. So, yung moment arm niya, the same lang. That is just yung D minus tong D prime natin. Kaya may makita kayong notation na D minus D prime, ano? And then alam natin to na AS, this is AS2, no? Sorry, this is a typo. AS2. This should be AS2. Okay? AS2 FY. Okay? Then, pag to minoment natin papunta doon, makukuha natin yung MN2. Or, mula dito, i-moment natin siya pababa dito, makukuha natin yung MN2 din. So, basically, kapag meron tayo ng value ng MN2, makukuha na natin yung value ng AS prime tsaka ng AS2. Okay? So, hindi siya laging equal. Kasi si AS dito, sa compression steel natin, hindi siya palaging nag-yield, ano? As we learned from our analysis. Pag nag-yield siya, yun lang yung time na equal yung dalawa. Okay? Yung AS2 tsaka AS prime natin. Okay? O yung moment capacity nito tsaka moment capacity nito. Mag-i-equal lang siya kapag nag-yield siya. Ngayon, pag hindi siya nag-yield, we need to calculate separately yung value ng Fs prime. And then, pwede natin pag-equity na lang yan. Pwede natin gamitin. Since this is a couple nga, no? Pwedeng CS is equals to T2. So, yung CS natin, that is AS Fs is equals to AS2 Fy. So, para makuha sa AS2, that is just AS prime Fs prime over Fy. Okay? Kung ayaw natin gamitin itong formulang to. Pero kung ano mang gagamitin natin, kung itong formulang to or itong formulang to para makuha sa AS2, it will be the same value. May konting discrepancy due to pag-round off ng numbers, pero basically the same value dapat siya. Okay? So, yan. So, pag may nakuha na tayong value ng AS prime tsaka AS2, yan, kukunin na natin yung pattern na papasok dun sa ating beam requirement with the requirements. Ano? So, yung AS natin will now be the combination ng AS max natin plus yung AS2, okay, na calculate natin. That is for our tensile reinforcement. And then yung compression reinforcement natin, manggagaling doon sa AS prime na na-solve natin. Okay? So, yan, ganun lang din po yan. Ganun po yung pag-select ng o kung paano i-design yung mismong section natin for doubly reinforced. Okay? Okay, so let's start with an example. So, design the beam with the following details. Let's say the beam has a width of 300, effective depth of 600. If it will be designed as doubly reinforced beam, 60 mm knowing distance from the top, we have F prime C is equals to 28, 420 ang Fy. And then we have the following loadings, 308.72 kilonewton meter. And then for live load, 174.71 kilonewton meter. Okay? So, pwede gawin nyo, once you see na yung F prime C natin, so pwedeng lagyan mo na agad ng beta, that is 0.85. Okay? Yan. So, let's start with our first step. Calculate for our moment. So, since moment na naman yung given, so that is just 1.2 md plus 1.6 ml. Okay, so 1.2 times 308.72 plus 1.6 times 174.71. So maximum moment natin for this section, 1.2 times 308.72 plus 1.6 times 174.71. That is 650 kilonewton meter. Okay. Next step, calculate for Mn. So Mu over phi. So that is 650 over 0.9. So 650 divided 0.9, that is 722.22 kilonewton meter. Okay. Next, step 3 is to calculate for our raw max. Okay. So, since hindi given kung anong code ang gagamitin, so assume ko na yung ACI yung gagamitin natin. So, 0.85, that is F prime C over Fy times beta 1 times 3 over 8. Okay. So, 0.85, we have 28 over 420. Beta 1 is 0.85 times 3/8. So, raw max is 0.85, 28 over 420, 0.85 times 3/8. That is equals to 0.0180625. Okay? Next, calculate natin yung AS max natin, ano? So, para makuha yon, we need a value for, so, yan na pala yung raw max natin, ano? So, AX max, so step 4 nga ba yun? Let's see. Step 4, yes, AS max. Okay, step 4. So, AS max, that is raw max, BD. So, that is 0.0180625 times, we have 300 and 600. AS max times 300 times 600, that is 3251.25 mm squared. Okay. So after getting that value, we need to calculate for the value of A para makuha natin yung moment, ano, na capacity niya. Okay. So, can calculate A is equals to, from yung formula natin na T is equals to C. So that is AS Fy is equals to 0.85 F prime C AB. So, pwede mo makuha si A as AS. So, gamitin natin maximum Fy all over 0.85 F prime C B. So, substitute 3251.25. We have 420 all over 0.85 times 28 times B natin is 300. Okay, value of A. So we have 3251.25, 420.85 times 28 times 300. That is 191.25 mm. Okay. Once na meron na tayo nun, I think we can now calculate our moment. Our moment, o yung ating M max for singly reinforced, o MN1 is equals to AS max Fy D minus A over 2. So that is 3251.25 times 420 times 600 minus 191.25 over 2. So we have MN1 is equals to 51.25 times 420 times 600, 191.25 over 2. Divide 1 million, we have 688.737 kilonewton meter. So let's compare that with our value ng MU. So si MN and N1 ay with our MU, ito yung MN natin, 722. Ito yung calculated natin. So that is less than our MU. Therefore, the RB siya or doubly reinforced beam siya. Okay? Okay. Next, let's continue. So, kung na-prove na natin na ganun, step 6 is to get the value of MN2. So that is MN minus MN1. So we have 722.22 minus 688.737. So MN2 is equals to 33.483 kilonewton meter. Okay. Then for step 7, you can now calculate the value of AS. So yung isa, MN2 is equals to AS prime, FS prime, D minus D prime. Okay? So, paano natin makakalculate sa FS prime? Okay? FS prime. So, from our strain diagram before, okay, ito ay 0.003. Okay? Ito yung ating ES prime. So, itong mga distances na to, that is C, and ito yung D minus C. C minus D prime rather. C minus D prime natin. So by ratio and proportion, we have 0.003 all over C is equals to ES prime is equals to C minus D prime. Okay? Pero alam natin na si stress. Okay. So, si Fs prime over strain. So, stress over strain equal yan sa modulus of elasticity natin. So, pwede natin gamitin Fs prime is equals to E times Es prime. Okay. So, whatever yung makuha nating value ng Es dito sa formulang to, multiply natin ng E para makuha natin yung Fs. Okay. So, we have Es prime is equals to 0.003 C minus D prime over C. Okay? So, ang E natin, alam natin that is equal to, naka-given din nata dito. Ay, hindi pala. So, that is 200,000 for steel. No? So, ibig sabihin, yung Fs prime natin, so that is Es prime times E. So, we have 0.003 C minus D prime over C times 200,000. Kaya meron tayong value na 600 times C minus D prime over C. Okay? So, makakalculate na natin ngayon si Fs prime. So, we have 600 times C. So, saan natin makukuha si C? May nakalculate tayo kanina na A is equals to 191.25 mm. Okay? So, si C is just A over beta 1. So, that is 191.25 divided by 0.85. So, C is equals to 225. Okay? So, dito, so 225 minus D prime natin ay 60 all over 225. Our Fs prime is now this is 440 megapascal. And ano yung value niyan? That is greater than dun sa ating Fy. Okay? Therefore, Fs prime, since nag-yield siya, okay, compression still yields, ano? Compression still yields. Okay? So, use Fs prime is equals to Fy. Okay? So, going back dito sa formula natin na to. So, As prime now will be equal to Mn2 over, kasi Fs prime natin gagawin na natin Fy. D minus D prime. So, we have 33.483 times 10 to the 6 over 420. D is 600 minus 60. So, As prime is 33.483 times 10 to the 6. 420, 600 minus 60. We have 147.63 mm squared. So, yan yung sa As prime natin. Ibig sabihin yan yung kailangan natin sa compression reinforcement. And, lagyan natin na ito yung A. And then, yung para sa tensile reinforcement natin, ng second section natin, okay, so As2, so from Mn2, that is As2 Fy d minus d prime. So, again, yung tension reinforcement natin, laging assume na nag-yield na yan. Ano? So, AS2 is equals to Mn2 over Fy d minus d prime. So, we have the same value, 33.483 times 10 to the 6 all over 420, 600 minus 60. Okay? And mapapansin nyo, yung equation niya is the same nito. Okay? Kasi nga, nag-yield yung steel. So definitely, makukuha nating value for AS2 is also 147.63 mm squared. Okay? So ngayon, yung buong section natin ngayon is for AS, yung kailangan natin for tensile reinforcement is AS max plus yung AS2 natin. Itong AS max natin, yan din yung AS1 natin. Ano? Parehas lang yan. So, that is yung na-calculate natin from previous slide. That is 3251.25. No? Itong value na to. So, 3251.25 plus 147.63. So, AS is 147.63. So, that is 3398.88 mm squared. And for our tensile reinforcement, ito na ngayon. Ano? So, ito na yung answers natin ngayon. Okay? Ito yung answers natin. Pero syempre, detailing meron tayo. No? Pero ito yung required natin na AS. Okay? So, papakita natin yung detailing natin. So, ito yung required natin. AS required. So, tingnan natin kung ano yung pwede natin i-provide. Okay? So, copy ko lang to sa other slide. Okay? Ayan. So, ito yung required natin. Ano? Ayan. So, for AS muna, sunod muna tayo sa tensile reinforcement. Kailangan natin 3398.88. So, punta tayo sa design aid natin. 3398 o 34 at least ang kailangan natin. So, kailangan natin ay 34. So, saan ba dito yan? Bawa isa 28 ang 34, 6 pieces ang kailangan natin. So, ilan ang 6 pieces na 28? 6 na 28 ay 36. Ano? Tingnan natin ano yung minimum width na kailangan for 6 pieces na 28. 6 pieces na 28, minimum width niya is 420. So, hindi pwede. Let's try let's try 4 pieces na 36. Okay? So, 4 pieces na 36 is 4 na 36. Ang required niya ay 368. So, pwede ba yung atin? So, parang hindi pa din, ano? Our width is 300. Okay? So, 300 yung required natin. So, masyado pa din siyang malaki. Or hindi pwede yung sa 4 pieces na 36. Ito, no? 4 pieces na 36. Ang required natin is 368. Okay? So, gawin natin 2 layers siguro, no? Try natin pag halimbawa dito, no? Bawa ito. Yung requirement para sa 8 pieces na 20. Okay? Tingnan natin. 8 pieces na 20, that is 2.5. Ay, hindi kaya, no? Kailangan natin at least 3, 4. Pag itong 6 pieces na 28 pero 2 layers, kailangan natin ng 328. Ang required lang is 252. So pwede, ano? Try natin ay 6 pieces na 28. So that is 3696. Pero gagawin natin 2 layer, kaya ang required width lang natin ay 3 pieces na 28, 252. So pasok yung 300 natin. Okay? So, lagay natin dito sa ating try. 6 pieces na diameter 28. Okay, 2 layers. Okay, so yung ES niyan is 628. So 6 pieces na 28, that is 3696. Okay? Tapos dito sa AS natin, kailangan natin is 147.63. So masyadong maliit lang 'yan, ano? So pwede siguro mga 2 pieces na 28 lang. Okay? Or mas smaller kasi malaki na 'yan eh. Gawin natin 2 pieces na 16. Yan yung pinaka pwede natin gamitin. 2 pieces na 16 is 402. Okay? So try 2 na 16. Okay? So ang AS niyan is 420. Okay? Then i-check nyo na lang sa NSCP requirement. Kayo nang bahala mag-check kasi we already done that several times. I hope you can check it on your own. Okay? So ito yung section natin ngayon. So meron tayong 6 na 28. So 1, 2, 1, 2, 3, 4, 5, 6. Okay? Then dalawang 16 dito. Palit. Okay? So, yan yung magiging section natin yan. So, this is our D prime. Okay? Yung ating D will be yung centroid nung atin yan. Okay? Then this is our 300 mm. Okay? So, yan yung section natin na required. Okay? Question dito sa first example natin. Okay? So, we can provide 216 sa taas tapos 628 sa baba. Okay? Alright. So, yan yung first example natin. Now, we proceed sa second one. Okay? So, halos same lang din naman. No? Medyo iba lang yung approach ng problem. Ay, yung pagkaka specify ng problem. So, if MU is 1225 kilonewton meter, determine the steel area required for the section shown. So should compression reinforcement compression reinforcement still be required? Assume that it will be placed 70 mm from the compression phase. Let's have F prime C is equals to 21 and Fy is equals to 420 and ES is equals to 200,000 megapascal. Okay, so we have effective depth of 700 and we have a base of 350. Okay, so okay, ganun lang ulit. Step 1, MU, yan given na. So 1225 kilonewton meter. Okay. Step 2 is MN. So MU over phi. So we have 1225 divide 0.9. We have 1361.11 kilonewton meter. Okay. Step 3, rho max. That is 0.85 times F prime C over Fy beta 1 times 3/8. Okay. Assuming ACI again. So 0.85. F prime C natin is 21. Then we have 420. Beta 1 for 21 is still 0.85 times 3/8. Rho max is 420 times 0.85 times 3/8. So we have 0.01355. Okay. So number 4 is for our AS max. That is just rho max BD. So that is 0.01355 times 350 times 700. So AS max, we have 3318.984 mm squared. Okay, and calculate for the value of A. We have AS max Fy all over 0.85 F prime CB. So kayo na yung mag-substitute. So times 420 all over 0.85, 21. And B natin is 350. We have a value of 223.125. Okay? So, yung moment natin, o Mn1, is equals to AS max Fy D minus A over 2. So we have 3318.984, 420, 700 minus 0.5 nung value ng A calculated, divide 1 million. That is Mn1 is equals to 820.266 kilonewton meter. And ano yung value natin? That is less than, okay, nung MU natin, nung MN natin. Okay? So therefore, doubly reinforced section tayo o beam. Okay? So, ayan. Meron tayong um, statement na siya ay doubly reinforced. So, step 4 is to get for Mn2. So, we have Mn minus Mn1. So, Mn natin is 1361.11 minus 820.266. So, Mn2 is 1361.11 minus, so we have 540.844 kilonewton meter. Okay, and calculate for AS AS2 natin tsaka AS prime. We have Mn2 is equals to AS prime, Fs prime, D minus D prime. So ang Fs natin, so from our derivation earlier, we have 600 times C minus D prime over C. So let's check, that is 600. So C value natin, nakuha natin A sa previous na ano natin is 223.125 mm. So C is equals to A over beta. So that is 223.125 divide 0.85. That is 262.5. So 262.5 minus 70 daw yung magiging distance ng compression reinforcement natin over 262.5. So Fs value natin, Fs prime, 600, 262.5 minus 70 over 262.5. We have a value okay. Tama ba yung formulang ginamit natin? Wait lang ha. C minus 262.5. Okay. Okay. So since yung value is again greater than dun sa ating ano no? This is 440. Okay? Greater than pa din siya dun sa ating Fy, which is 420. Therefore, compression still yields ulit tayo. Okay? So, ibig sabihin yung fs prime natin is equals to fy. Okay? Ibig din sabihin nun, pag nag-yield siya, ang as prime natin ay equals kay as2. Okay? Dito lang yan, pag nag-yield siya. Pag hindi siya again nag-yield, so iba ang solution ng as prime. So using this formula, then kay as2 is using yung formula na isa. Okay? So we have as prime is equal no to mn2 all over fy na to kasi nag-yield siya. So d minus d prime. So that is mn2, that is 540.844 times 10 to the 6, 420. Then we have 700 minus 70. So as prime is 540.844 times 10 to the 6, 420, 700 minus 70. We have 2044.006, okay, mm squared. So yan din yung ating value ng as2. Okay? So ang as natin ngayon will be as max plus as2. So kung ano yung max natin kanina, yung max natin is this value. So pa-add lang natin. Okay? So yung para sa tensile reinforcement natin, it will be 5362.99 o 5363. Okay? So ito yung kailangan nating lagyan ng reinforcement detail. Okay? So dito, five three six three. AS is equals to 5363 mm squared. Okay? So looking at our table, okay, so 5363 muna yung AS muna natin. 5363 ang kailangan natin. 53. So ito no, 7 pieces. So mahirap mag-divide pag 7 pieces. So try natin ay ito no, pwedeng 8 pieces. Oh, hindi. Ito lang. 6 pieces na 36 mm. Okay? Kailangan ng 6 pieces na 36. Kailangan niya is 512. So pwede natin gawing 2 layers 'yon. Or pwedeng 28 mm, no? So, wala naman specify. So gawin natin 36 na lang. So 36, 6 pieces na 36. So try natin. Try 636. Okay? So try 636. Ang AS nito is 6108. So 6108 mm squared. Okay? So again, ang requirement para sa 6 pieces na 36 ay 512. Pero pag 3 pieces lang siya na 36, that is 296. So pwede yung 350 na width. Okay? So gagawin natin tong 2 layers. Next yung sa AS prime. So 2044 yung kailangan natin. So 2044. So pag 36 na 3 pieces, that is 3054. Okay? Pag halimbawa 3, kailangan ay 2044 lang kailangan natin, ano? So pinapattern ko kasi yung magtatapat yung mga bakal, ano? Kaya dito ako sa 3 pieces tumitingin. So pag 3 pieces na 32, pasado naman siya, no? 3 pieces na 32, 3 na 32, 268, walang problema. That is 2412. So medyo may pasobra na tayo dito. Kasi 2,044 lang kailangan natin, ano? So, try natin 332. So, that is try 3 pieces na 32. So, yung AS nito is 2412. Okay? Again, check nyo lang yung kung mag-yield yung steel ng tension, reinforcement, and then tsaka natin pwedeng i-verify, ano? Pero again, i-aasa ko na yung pagche-check sa inyo, ano? Ayan. So, we have 2 layers na 6. So, 3 layers yun. So, 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3. Okay? So, this is located at 70 mm from top. This is 700 from top. This is 350. And then, ito, lagyan natin ng call out. That is 6 na 36. And then this is 3 na 32. Okay? So, ayan yung ating doubly reinforced section. Okay? Question po? Okay? Walang question? Alright, kung no question, ayan, this ends our lecture for this topic. Okay? And this is the first part of our finals exam.